Hello there. Let's talk about how to convert decimal numbers with fractions into binary numbers with fractions and vice versa. So up to this point, if you've been watching my other videos, you probably know that you can easily convert a decimal number to binary and binary to decimal if the decimal and binary numbers are whole numbers. But in order to progress towards IEEE 754 representation, in other words, in order to eventually be able to represent binary numbers with fractions like floats or doubles in the machine, you have to start learning how to get the fraction part of a decimal number into binary. The way we're going to do it in this video, it's not actually going to be the final representation of how your machine stores floating point numbers, but it's an important step on the way there. Without this step, you probably wouldn't be able to do it. So what am I talking about? I'm just going to open up this notepad real fast and just show you that what I really mean is, suppose we have like a number 45 point blah, 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 right? So this is the whole part and this is the fractional part. Okay, no problem. Also in binary, we have like a bunch of ones and zeros. This is a whole number, but we could put a decimal point and then just start doing more numbers after the decimal point in order to represent a fractional binary number. Okay, so let's see. We know, hopefully at this point, if you watch my other videos, that, I don't know, I'm just going to put some random numbers here and then like some more random numbers there. And you know that the strength of each of these numbers is sort of like increasing by powers of 2 on the left side, on the whole side. So the strength of that first digit is 1. The next digit has a strength of 2, and then 4, and then 8, and then 16. Maybe I'll put the 6 up here. And then 32, so 3 and 2, and then 64. And maybe I'll do another digit. I'll just put like a 0 there. And then, the leftmost digit has a strength of 128. So basically, to figure out what the whole part means here, you're just taking a 1 or a 0 for the actual binary number multiplied by its strength. So 1 times 1 is 1. Add that to 0 times 2, add that to 1 times 4, and 0 times 8, and 1 times 16, and so forth, right? So hopefully we know how to do that at this point. To do the same thing on the fractional side, maybe I won't put a decimal marker there. It's really the same deal, except as we go left, we were multiplying by 2 because the numbers or the digits should have more power, more strength. But as we go to the right, past the decimal point, they should have less strength, and we'll just divide them by 2. So pretty much at this point, let's see, we'll have 1/2 will be the strength of this digit right here. Whoops. 1/2. So the strength that that digit has is just 1/2. The strength that the next digit has is going to be 1/4. Remember, you divide by 2 each time. Whoops, I'm getting lost. Oh man, I probably need to add some spaces because it's starting to get pretty ugly. So this digit has a strength of 1/2, this digit has a strength of 1/4, and then we'll just say that the next one has a strength of 1/8, and so forth. We'll just keep dividing by 2 each time. So don't forget that. Don't make the mistake of saying 1/4, or sorry, don't make the mistake of saying 1/2, 1/3, 1/4. Don't increase the denominator by 1. You want to you want to divide by 2 each time. Or if you want to say the word multiplication, then you multiply by 0.5, I guess, if you want to. I'm just going to write 1/16 and then just be done with the divisions. I hope you understand what I'm talking about. We're going to do some examples right now. Okay, so let's calculate. Well, actually, let's just to emphasize, just to make sure everybody understands, what we would do to convert such a number from binary to decimal would basically be, compute the left side as if it were a whole number. I'm going to put W for whole number. And then separately convert the fractional part as if it were just, 0 point something. And then just combine the two things when you're in decimal. And you'll do the same thing when converting a number from decimal to binary. You convert the whole part first, put that into ones and zeros, then convert the fractional part into a fractional binary part, and then just combine them across the decimal point. So let's do an example. Let's start with converting 0.126 753. I don't think that this number is going to resolve easily. It's kind of like a good lesson here. When you're converting between binary and decimal, there are always going to be some numbers in decimal that you can't represent in binary, and vice versa. There are always going to be some numbers in binary that you can't represent in decimal. So it's not that decimal or binary are, superior or inferior. I mean, all technology is pretty much running on binary, so it can't be that bad. But just keep that in mind. Some numbers that you type randomly are just never going to resolve, and you'll have to give up at some point and say, well, we're just going to call this a precision loss, because we just have to give up, especially if you only have so many bits to put the fraction in. Okay, so what am I going to do? What's the basic algorithm here? There are lots of different ways to do it. The way that I'm going to show you is just multiplying by 2. So if we take 0.126753 and we multiply it by 2, we end up with, let's see, times 2. Oops, hello. Oh, I got to do that. Times 2. We're going to end up with a different number. If the number is equal to or greater than 1, then we will say that we have achieved a number of 1 for the converted binary number. And if not, we'll say we have achieved a number of 0. If the number is 1, we'll also subtract 1 from the remaining number here in decimal. So in this case, the result we have is just, what's going on? Oh, I somehow turned on my annotator. Okay. In this case, we just have, this number right here. It's not greater than 1 or equal to 1. So I'm just going to say this gave us a binary number of 0. And because it gave us a 0, we're not actually going to change it at all. We're not going to subtract 1 from it. We're just going to leave it as is. We will then multiply by 2 again. So I'm just going to say, do it one more time. We'll say this multiplied by 2, and it's going to be this number. Again, it did not exceed or equal 1, so the bit in that position is going to be a 0, and we'll just copy and carry it over just as is. Do it again, and we'll say multiply by 2. Now we have a number that equals or exceeds 1, so we've achieved a 1 in the binary position, so it's going to be a 1 here. Then we got to subtract 1, so we're just going to be left with 0.014, 024, and whatever. And then we just continue. Maybe I'll do it a couple more times, but I'm going to give up because I don't think that this number will translate completely. So I'm going to say multiply by 2 again, and it's going to give us... Oh, hang on a second here. What was that? That was 1. Oh, I forgot to subtract 1. So I got to subtract 1. And then I'm going to multiply by 2. Now we get this number right there. This is not equal to or greater than 1, so the bit is going to be 0. And then that means the remaining number is just going to be the same thing. We'll do another. Actually, let me clean the calculator for a second here. I'm going to select this whole thing and just paste that. And I'm going to say multiplied by 2. That's going to be that new number. And I think you're starting to understand why I want to give up, because we'll just be kind of doing this forever. This might end up being an irrational number in binary. I don't really know. I haven't gone that far. But it's definitely going to take a long time. So I'm going to give up, and I'm just going to say, all right, the final binary number is going to be 0.00100, and then just say, maybe there's some more stuff at the end. We'll just call this a precision loss. You can see, maybe I should do one more number actually, because it's kind of a mirror. There's like 2 zeros and then a 1 and then 2 zeros on the other side. Let me multiply this by 2 real fast, just to show you without symmetry what would happen. So I'm going to multiply that by 2, and it's going to be this number right here. So that's going to be 0 because it didn't exceed or meet 1. And so the number we have left over is just that. Okay, so now because there's no symmetry, you can see that the number is going to be 0.001000. We go from top to bottom. We don't do any kind of reversal like you might do with whole number binary conversion. I don't know. Maybe it'll be 0 for a long time and never, or yeah, there'll probably be some 1s in there at least. I don't know if it's ever going to resolve. You'll know you're finished when the leftover number here is 0. So again, I'm just going to give up on this because I don't really know if it's going to work. Let's do a number that I know is going to resolve. I have this one prepared in advance. So let's do 0.84375. Okay. So how do we convert this? Again, just multiply by 2. Every single time you meet or exceed 1, then you'll say that we have a 1 in the binary number, and then subtract 1 after that. And if not, we will say that we have a 0 in the binary position, and then we won't subtract 1. Okay, so that number multiplied by 2 is going to be 0.16875. So that's definitely greater than or equal to 1. So I'm going to say we have a 1 in the binary position. And then the next number is going to just be 0.6875. Okay. Now we take that number, 6875. You could also just, in your calculator, you could say -1, and then we'll multiply it by 2 to get the next bit. The number is going to be 1.375, so I'm going to write 1.375 here, and then it's greater than or equal to 1, so it's going to be another 1 here. And then after we subtract 1, it's going to be 375. No problem. Okay. So let me just -1 here, and then multiply by 2 to get to the next bit position. It's going to be 0.75. All right, so 0.75, that number is less than 1, so we have a 0 in that bit position. We also don't subtract anything because we had a 0 in that bit position. Then we just multiply by 2 again. Multiply by 2. Now we have 1.5 because that's greater than or equal to 1. We have a 1 in that bits position. Then we subtract 1. It's just going to be 0.5. That should be pretty easy, right? Because that sounds like there's a 1 in a bit, and then it's just done after that. So I'm going to do -1 and then multiply by 2 again. Notice how that is exactly a 1. So it's going to be 1.0, which means we have a 1 in the position because it is equal to or greater than 1. And then, well, what we have left over is 0. 0 multiplied by 2 is going to be 0. So that means if we kept doing this forever, then all the numbers down here are just going to be zeros forever. And I said in another video, when you realize what's going on with the zeros, like where are they? Are they on the left or the right? When you're converting a whole number from binary to decimal or decimal to binary, the zeros would be on the left side. So that's why we would reverse, because if you just add infinity zeros on the left of a whole number, you're not changing the value. But if you added them to the right, you'd be increasing the value. When it comes to the fractions, the right side of the fraction won't change the number. For example, if we had 1 point and then some random binary numbers, if we just kept adding zeros on the right side, that's not changing the value of the number because this is the fractional part. However, if we started adding numbers on the left side, then we would make the fractional part smaller and smaller and smaller. So that means the zeros have to be on the right side. And you can see here, the right side is the bottom. So that means we're going to take these numbers. I'll just put etc. here, just so you can see, etc. That means we're going from top to bottom. So the final number is 0.11011. And then a bunch of zeros after that are just, nothing. And that's the final answer. We now have 0.84375 is equal to binary that number, and we'll just say OB to indicate that the following is a binary number. Because again, you could have a decimal number and then have a bunch of ones and zeros in the fraction part, I guess. So to make sure that the reader understands what they're seeing, you'll say OB to indicate this is a binary number. On exams or quizzes, if you're out there doing this for an exam or a quiz, keep in mind you probably want to talk to a professor to make sure that OB is supposed to be part of your answer. They might just want this. It depends. Anyway, so 0.11011. Okay. Then let's convert it back again. Let's convert this number to the original decimal number there. Okay. So how can we do that? Pretty much just start adding the fractions up. So remember, the first fraction that we see is going to be 1/2. 1/2. And the second fraction we see is going to be 1/4. And then we just keep multiplying. 1/4, 1/2. Maybe I should write this in a notepad here. We'll see 1/2 plus 1/4 plus 1/8. And some of these bits aren't going to count. Like, for instance, the 1/8, it's not going to count towards the fraction. But for me personally, if I forget to type 1/8, I'm probably going to accidentally use it for the next position. So I'm just going to type everything one at a time. So let's see, we have 1, 2, 3, 4, 5. 1, 2, 3, 4. So I got to do one more plus 1/32, and then multiply by the bits. So say like 1 times that, and then 1 times that, and then 0 times that to basically cancel it out, and then 1 times that, and then 1 times that. Plug it all into the calculator. Let's see if I got that right. 0.84375. So that's how you convert back from binary to decimal. Pretty easy. And then also, of course, when you're practicing this, you want to try with a bunch of different random numbers to start off with. You just want to be careful. Again, this process could take forever if you have like the wrong number that you start with. But I guess at least when we're converting from binary to decimal, it's going to end up resolving to something. It won't necessarily be something that you can't represent. But if you start up with a random number in decimal, there's a chance maybe it's not going to work with binary. Okay, or you'll have to give up and call it a precision loss. Okay, so then now let's ask, what if we had a complex number? Because we know how to do this now with just the fractional part. But what if we had a number that was a little bit more difficult? Let's say we have. Oh, wait a minute. 804, 375. Oh, I think I just accidentally did a totally different number than I wanted to on my plan. Luckily, I got the right answer. Okay. Anyway, what if we had a more complicated number? Let's see, 804, 6875. Okay, so 804, 6875, but with a 45 in front of that. Remember we said before that this is the whole part and this is the fractional part, and you just want to do them separately and then combine them afterwards. So the whole part, let's see, what is that going to be? I'm just going to say that this is not a video for whole number binary conversion. This is just dealing with fractions. Find my other videos if you want to know how to convert the whole part. But I'm going to say that 45 is just this number in binary. And you can double check real fast. You can say 1 plus, here, let's do it again. Let's do it just to be sure. 1 plus not a 2, because there's a 0 there. And then we'll say 4 plus 8 plus not a 16, because there's a 0 there, and then plus 32. Add that together, that's 45. So the whole number part is pretty easy if you already know how binary conversion. But now let's convert 0.804, whoops, screenshot, no thank you. 0.8046875. So I'm going to have to do this from scratch since this is a different number than I just worked with. We'll do that multiplied by 2, and it's going to be this number, 609375. Is that really not the same number? 609, yeah, I guess I really just did a different number. Okay, so that means we're going to have a 1 in the binary position, and the remaining fractional part is just going to be this. Whoops, 0 point that. So then we take that number and bring it down, multiply it by 2. Whoops, not supposed to actually bring that part down. We'll bring it into the calculator. We'll multiply it by 2. Actually, let me get that again and subtract 1 just to double check myself. It's always good to double check yourself. Then we'll multiply this by 2, and then the number is going to be 1.28. So we have that. And then since it's either equal to or greater than 1, it's going to be, a 1 in the binary position. So 0.21875 is going to be the remainder there. So I'm going to do -1 and then times 2 to make sure the calculator agrees with me. Whoops. 21875. Okay, then I'll do a multiply by 2 to get the next number. 4375. And that's not equal to or greater than 1, so we'll put a 0 there, and we won't subtract anything, so it's just going to be 0.4375 again. Then we'll multiply that by 2 to get the next number, times 2. It's going to be 0.875, so 0.875. Again, this is not 1 or greater, so we have 0 in the binary position, and we don't subtract anything, 0.875. Multiply by 2 again, times 2, so it's going to be 1.75, 1.75, and then of course we'll have a 1 in the binary position, and the leftover is going to be 0.75. So let me just go back to the calculator and I'll say minus 1 times 2, it'll give us 1.5. So 1.5 over here means we'll have a 1 in the binary position because it was equal to or greater than 1. The leftover is going to be 0.5. Now you know we're about to finish, because 0.5 times 2 is just going to be 1.0, which will give us a 1 for the binary part, and then the remainder is going to be 0.0. And then, you know, there's no need to multiply 0 by 2 because it is forever going to just be zeros. Maybe I'll just write it out one more time just so you know. 0, 0, 0, right? Remember that? So that means, of course, the zeros are on the right side of the fractional part, and on the left side is going to be 0.110011. And so I'll just put 0.1100111. And then now we just have to combine those two numbers. So maybe just I'll put something here indicating that this is the conversion of just that number, like that. Now we'll combine both of those parts, right? So 45 was this. So I'll say maybe therefore this big number right here, this complicated number, is equal to combine this number for 45, and then I'll just put a decimal point, and then I'll put the fractional part on the right side, and then let me just double check my work real fast. It should be 10110111. Wait, what? No. 101101, and then 11001111. Okay, so that's it. We've converted a complicated decimal number into binary, and we can do it in the reverse, just using the same thing. You know, step 1, convert this number into a whole number of decimal, and then step 2, convert this number into a whole number, sorry, a just only fractional number for decimal by just getting the 1/2 plus 1/4 and so forth. And then just, you know, put them around a decimal point. Just for practice, okay, I'll go ahead and do it. Some of you are probably like, well, why won't you do it? I'll do it, okay. So just only looking at the fractional part, because this is not a video to convert whole numbers in binary and decimal, but just to convert the fractional part only, I'm going to do, let's see, say, whoops. Maybe I need to put that over there. Okay. So starting with just this one right here, it's going to be 1/2 plus 1/4 plus not 1/8, not 1/16, a 32. 132 plus 1/64 plus 1/128. 128, and then if you look at the result, it should be 0.8046875. So it looks like we succeeded. Okay, so now we know how to convert a decimal number with a fraction into a binary number with a fraction, and we also know how to convert a binary number with a fraction to a decimal number with a fraction. That feels like a long video. Let's see what it is after I cut this. Thank you so much for watching. I hope you learned a little bit of stuff and you had a little bit of fun. I will see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.